Well, Frankie, he is our contact. He is our first contact with Ibarmia, and together I think we had very good solutions. So we can say this is now one of the fastest Ibarmias in the world.
Henk, I've been doing this job a long time, and I reckon this is one of the let's say the best engineered solutions I've seen. It's all come together over the course of the last couple of years. Can you tell us what is happening here and why you invested in this cell?
So first of all, we have a production of our weaving frames here. The base is actually 2 aluminum profiles, and we have to machine them. We have to do it inside a target time of 70 seconds. So therefore, we need to design and to develop a machine based on a standard machine. What you see here is actually more or less a standard ZV40 extreme machine. But we changed a lot of it. First of all, you see 2 pendle stations, a left station and a right station, and in front of that station, 2 robots.
What was the problem that you were having before, though? What sparked this new solution?
So we did it before with a special machine, a very special customized machine. We could only produce this profile with this machine. Here we have more or less a standard machine. Later on we can maybe machine other things with that machine also. But first of all, we need to machine our aluminium profiles.
So you've got 2 Ibarmia. Is this one Ibarmia machine? I mean, it's about 8 meters in length, 4 meters a side.
This one has an X travel of 9,400 millimeter, and we have actually one machine, but with 2 columns and 2 spindles. So it's one machine bed, one machine base, with 2 spindles and 2 columns on the machine. And we divide it in 2 parts of approximately 4,500 millimeter X course. So, and we have with these 2 spindles the possibility to work simultaneously in one station.
So your profiles, though, these are part of the weaving machines. Can you explain for those that don't know what Picanol does? What's the end product?
So the end product is a high quality weaving machine. With the weaving machine we can produce all kinds of textile. The most famous one is maybe jeans. I think 1/3 of all the jeans is woven on a Picanol machine. So this is
I haven't got any on today.
Yeah, maybe also yours.
Yeah. But what are the parts that you're doing on this solution then? Is it one profile per weaving machine? Is there 2? What?
No, you can have several profiles or several weaving frames. In one weaving frame we have always 2 aluminum profiles, and you can have up to 24 weaving frames in one machine. We take as average 12 weaving frames per machine.
And all of those will come through this cell then, will they?
All of them comes to this cell. So we start here with a sewing operation where we more or less bring them on the right length. And then we put them in the machine on the trunnion with a robot, and we machine them completely.
What's the machining? What are you doing? Just milling, or?
We do all kinds of milling operations. So first of all, we make it on the right length, and then we have to mill some slots in the part, and also some boring operations.
Okay, and this is all within a target time of, did you say 70 seconds per part?
70 seconds per part. So per profile we have 8 profiles in each station. So the target was that the spindles can continue running. When one station is finished, they move to the other station. They don't move, they fly to the other station, and there they start again. While they are busy in the other station, we can load and unload the station that is finished with the robot.
There's something clever you're doing digitally as well. All of these parts are traceable, aren't they? You've got...
Yes, at the start, after the sewing operation, we have a laser marker, and there we laser a DMC code in the part. This is a kind of product passport that we use later to control everything, also the machines. So when the part is arriving in front of the machine, we scan the code, we give it to the software system, and the software gives automatically the desired information to robots or to the Ibarmia machine. such as, for example, the program that he need to use to machine them.
Is this your idea or Ibarmia's, or who? How's it all come together?
So we had in the start an idea, a basic idea. We went to Ibarmia with that idea, and together we designed the machine. We designed in the first time 2 different machines, and we choose for this solution because it's very close. Even you don't see it maybe, but it's very close to their standard, and this was important for us.
Yeah, I mean, the spindles on here, like 20,000 RPM, 60 kilowatt. You've got obviously flood coolant on here. You've got to keep the place clean. They've even got some fairly unique 4th axis units, I believe, haven't they? With the indexing system.
Yes, we have 2 rotary tables. We can clamp it hydraulically, but it's not necessary for these parts. We can keep them under control with the motors on this rotary table.
What's the biggest challenge hitting the cycle time? Was that the really key thing? You've got to get that cycle time.
The biggest challenge was, you need a high dynamic, very fast machine. So therefore, we improved the acceleration and deceleration speeds. So Ibarmia did a lot for that. So we can say this is now one of the fastest Ibarmias in the world, I think. And on the other hand, we had to check how that we can load and unload also the parts inside the time that he is busy in the other station. Therefore, we have designed very special vertical opening doors. Normal is a horizontal opening door that takes more or less 16 seconds to open. Now we do it inside 4 seconds.